Hey everyone, welcome to the channel. Today, we're looking at some shocking facts about the moon rocket impact. Let's head over to the screen and get started.
Welcome to This Explainer. Today, we're diving headfirst into an event that recently sent the entire internet into an absolute panic. I mean, rumors were swirling, doomsday theories were trending everywhere, and people were seriously questioning the future of our planet. So we're going to take a really close look at the actual facts behind this rogue rocket that slammed right into the surface of our moon. We'll separate the viral fiction from the scientific reality using exactly what the data tells us. Let's get into it. Now, to really wrap our heads around the magnitude of this event, you've got to picture the terrifying speed of this impact. This rocket wasn't just, drifting lazily through the vacuum of space. It was absolutely hurtling at a blistering 5,400 miles per hour. To put that into perspective, that is roughly 7 times the speed of sound. At that velocity, the kinetic energy is just massive, which is exactly why this collision grabbed the attention of astronomers and the public all around the globe. And the crazy thing is, this wasn't some hypothetical scenario in a distant sci-fi future. This high-speed lunar collision took place on a very specific date, August 5th, 2026. On that exact day, a human-made object traveling at hypersonic speeds literally met the ancient silent surface of the moon. But you're probably wondering, how exactly did a rocket end up on a collision course with our lunar neighbor in the first place? Well, let's dive into part 1, the SpaceX moon crash. So the object in question definitely didn't come from some alien civilization. It was actually a piece of hardware from Elon Musk's aerospace company, SpaceX. If we trace the rocket's journey, it takes us back to January 2025, when a SpaceX Falcon 9 rocket was successfully launched. It did its job, completing its primary mission perfectly. But after its fuel was spent and its purpose fulfilled, a massive section of that rocket just didn't return to Earth. Instead, from 2025 to 2026, it drifted aimlessly in the void as space junk. Eventually, it wandered just a little too close to the moon, lunar gravity took over, pulled the dead rocket in, and boom, that led to the dramatic crash in August 2026. Moving right along to part 2, assessing the crater damage. Okay, so now that we know how it got there, let's step into the shoes of an investigator and examine the crime scene left behind. I mean, what kind of scar does a rocket traveling 7 times the speed of sound actually leave? Well, the physical aftermath was violent, to say the least. The collision gouged out a brand new crater roughly 60 feet wide and 12 feet deep. And the impact was so incredibly intense that it didn't just leave a dent, it kicked up this massive plume of lunar dust and soil that shot kilometers up into space. In fact, that dust plume was so enormous, it was detected by powerful telescopes right here on Earth. So just laying out the core crash data neutrally for a second, before we get into all those wild theories that followed, we are dealing with a 4-ton segment of a SpaceX Falcon 9 rocket crashing at 7 times the speed of sound. 4 tons of solid metal hitting rock at that speed creates a formidable release of energy. And honestly, it was this exact set of numbers that fueled all that incredible public anxiety in the days that followed. Which brings us to part 3, Earth's tides and eclipses. Man, when the public heard about a 4-ton rocket slamming into the moon at 5,400 miles per hour, people were genuinely terrified about Earth's impending doom. They started worrying about our deep fundamental connection to the moon, and what would actually happen if that connection was severed or even just altered. And the panic was based on real scientific principles. They were just taken to absolute extreme theoretical scenarios. It was basically a terrifying domino effect. First, people theorized the sheer force of the impact might knock the moon slightly out of its orbit, and if the orbit shifted, it would disrupt the moon's gravitational pull on Earth, which completely controls our ocean tides, right? That would throw the entire marine ecosystem into chaos. Second, people feared that if the angle of the moon was altered even slightly, the delicate, perfect alignment required for solar eclipses would be permanently ruined. So it naturally leads to this chilling hypothetical question that was suddenly on everyone's mind. Could this one crash destroy the delicate balance of our solar system? And it's a highly valid concern for anyone who doesn't spend their days crunching astrophysical mass equations. If our tides and our eclipses depend on this perfectly balanced dance between the Earth, Sun, and Moon, could a rogue human rocket bring it all crashing down? Let's take a deep breath and look at part 4, the scientific reality. Because while the internet was absolutely panicking, global space agencies were quietly busy doing the math. And we can all breathe a massive sigh of relief here. This definitive consensus from NASA and scientists worldwide sums it up perfectly. They stated, The Earth, Sun, and Moon are completely safe with zero threat from this impact. They came out quickly and firmly to debunk the viral panic. The intricate balance of our solar system remains perfectly intact, and the Moon is still shining exactly as it always has. To really understand why there was zero threat, you just have to look at the scale of things. The Moon's weight and size are so incomprehensibly massive that a 4-ton rocket is practically a microscopic speck of dust to it. Just imagine a single grain of sand pinging off a massive boulder. That is the kind of scale we were talking about here. The rocket might have been traveling super fast, but against the sheer, monumental mass of the Moon, its impact energy was essentially nothing. So, the crucial point to take away is 0 millimeters. That is exactly how much the Moon's orbit, trajectory, and gravity were actually affected by this highly publicized crash. Not a single millimeter of change. The tides are totally safe, the solar eclipses will continue exactly on schedule, and the celestial mechanics of our Earth-Moon system haven't even registered the bump. Actually, there is a fantastic plot twist to this whole story. This sensationalized disaster turned out to be a massive win for science. Remember that huge plume of dust we talked about earlier? Because the rocket hit so hard and dug a 12-foot deep crater, it kicked up deep lunar soil that has been hidden away for literally billions of years. By observing that specific dust plume from Earth, scientists are getting a rare, free look at the Moon's interior composition, which is huge for helping us understand more about exactly how it was formed. Finally, let's pivot to part 5, the real space junk threat. Now, we shouldn't just laugh off this whole event just because the Moon survived. The real threat here isn't lunar destruction. It's the rapidly growing issue of space junk. Space junk is essentially discarded human-made debris floating aimlessly in space. And this Falcon 9 segment is just one piece out of thousands of discarded dead rocket parts cluttering our orbital highways. Every single time we launch satellites or missions and just leave the spent hardware up there, we are exacerbating a massive pollution problem in the vacuum of space, which is creating hazardous conditions for future exploration. Which leaves us with a really provocative thought to ponder as we wrap up this explainer. As human space junk continues to increase, are we polluting our solar system's future? The SpaceX lunar crash definitely wasn't the end of the world, but it was a massive 5,400-mile-per-hour wake-up call. It's a stark reminder that our reach into space comes with a heavy responsibility to keep it clean. Thank you so much for joining me today to unpack the facts behind the fiction.